Thanks for watching my video today. I'm Mr. Pilarski, and what we're going to be talking about today is Turning Technologies, Turning Key Software. You can see I have two applications by Turning Technologies. I have Turning Point Anywhere. It's going to be for a future video. Today's focus is going to be on Turning Key. And what Turning Key is a self-paced testing responder unit, clickers if you will, in the classroom. At some point I'll get a video posted with the clickers and how to use those a little bit. Today's going to be about data collection and data-driven instruction. What you're seeing is a session that I saved through this Turning Key software, and it gives me the results from my classes. And you can see here I have the students sorted by their total score. Each problem was worth 4 points, 20 questions, so a total of 20 problems. You can see a few students have finished it, but you can see a lot of those students have, especially the later problems, wrong. I think they were focused and wanted to rush to get it done before the end of the period. Maybe I was unclear on the directions, said take your time. It is going to be a 2-day assignment because we did introduce this really for the first time with this pre-test, if you will, this practice test for their upcoming unit exam. What I found in using this technology, and I'm going to explain a little bit in a minute, but what I found is it really increased student engagement. I had the students work in groups of 4 to 5, and each group has a student leader in which a student is mathematically strong. I try to encourage the students to engage in conversations that are related to the problems they're trying to solve. Most students work individually, where I try to model and get them to work together, solve one problem, compare their answers, see who's right, who's wrong, or have a discussion about who's right or who's wrong, and then if they can't figure that out or explain it to each other, then myself or my co-teacher will step in and help explain the problem. My conversations today with my students using this Turning Key technology was very directed. The students' questions were very directed, and I'm going to actually get into that when I get into the problem that you're going to see the data here. And in fact, speaking of data here, what I have is 1 period's worth of data. You can see the students are sorted by the total score. Each problem was worth 4 points. Total of 20 problems, so that's going to be 80 points. So what I did is I collected this data into a table. You're going to see that table in a little later in the video, and went through and collected this into a table. We can see in this particular period, problem number 1, all of the students that were apparently present in class participated in problem number 1. And for problem number 2, we can see more students got that problem wrong. I think for that particular period, 8 students got that wrong. At that point, I'm counting the students still present in class. The students new to the class just started a few days ago, right at the end of the unit. So really maybe not sure what's going on. So could be a reason for his disengagement in the lesson. Problem 3, continued participation except for that last student. And problem 4, we can see. And obviously each check means the student got the problem right. The X, the red X, means they got it wrong. So we're going to see how we're going to use this data to drive instruction, at least for the beginning of the period tomorrow, to review what they did the day before. So here's kind of really cool because students, and if we look at this student here, the second student down, they got the first 13 problems right. Every problem they got right that they did, which is really cool, and they got further than the average. The class average here is about 8.5. And when that student got to problem 6 or 7, I stopped him and said, hey, you're doing a really good job. You got all the problems right so far. And that student, when they weren't sure about one, in fact, came to me, asked me about number 5. We had a meaningful discussion about it, and it was really exciting for me as a teacher. I really got through that day, and it was a very cool day. I had a lot of fun with it. I hope it goes this well tomorrow. Anyway, so we're going to move into seeing the data now, and after that, we're going to roll into how I'm going to at least use one of the problems tomorrow in class to get class started. But what I have in my hand is the data I collected from my classes that I showed you from the Turning Point. And if we want to take a look at this up close for a minute, you have to mind me. I'm going to hide behind my nerdiness, hide behind my math. But anyway, you can see I got it broken down by periods. Along here is the number of problems 1 through 20. You can see that each class averaged right around completing a total of 8 to 9 problems. The later in the day, the more problems that got done. We can see, if we just look down here, here's the totals for each problem wrong, starting with problem 1 here. And as you can see, problem 5, problem 3, problem 2, overall, just because of the data, because of the numbers overall. Now we can take a look at that as an individual class basis, but we're going to focus on problem 5 for that. If we take a look at this data here, period 1, 11 students got that wrong. That's about half. Only 2 students got that wrong in period 2, but that's about normal in period 2 if you look at the rest of the data, problems 1 through 8. Taking a look at period 4, 10 students got that problem wrong, or actually at period 4 or 5 on problem 5. 10 problem students got that wrong. Again, that's just about half. And finally, period 12, we have 13 students getting that wrong. Total 36 out of the students that participated in today's Unit 4 test review got problem 5 wrong. And I'm going to proceed in the video and take a look at why problems got it wrong. Or students got the problem wrong. Most of the time, they're going to find out, we're going to find out in the upcoming segment of the video, that the students set up the problem right, but it's a misunderstanding of numbers that causes the problem. So we're going to take a look at that, and we're going to explain that in relation to the problem that we're reviewing here in solving proportions. Here's problem 5 from my data. This is just a small part of my data-driven instruction. This is the problem, our current unit's ratios and proportions. This is a classic proportion problem. We can see here I have my data. These typed numbers are the number of students that chose A, that chose B, that chose C, and chose D. We can see the highest number of students chose D, which is the correct answer. Now these handwritten numbers are the answers. And down here I had 1 student not respond that was present in class. That would be certainly, if this type of thing continues, it'd be something to bring up with the parents about the non-participation in class. Quickly showing how this problem should be solved properly. In class, we had a discussion about this type of problem. School guidelines require that there must be at least 2 chaperones for every 25 students going on a school trip. How many chaperones must there be for 80? Now, I would start this problem off personally by using a verbal ratio. I know to use a verbal ratio because in the first sentence, 2 things are compared. It tells us that we need, for every 25 students, for at least 2 chaperones. So that means 2 or more for every 25 students. So I get the words from reading comprehension, reading the problem and understanding. 2 chaperones for every 25 students. From there, I'll make a proportion. And on the left side of my proportion, I'll put the number of chaperones in the numerator, 2, and the number of students in the denominator, 25. On the right-hand side, I get my information from the question sentence. How many chaperones? That is telling me that's what I need to find. How many chaperones? So in the numerator, I put the X because that's the number of chaperones. Must there be for 80 students? That's the denominator. We solve this problem with cross products. 80 times 2. That gives 160. 25 times X. That gives 25X. Now I can write the equation because of the cross products property from algebra. Cross products of a proportion are equal. We solve this simple equation by dividing by 25. Now there's a less algebraic way to do that. When we divide this out, 160 divided by 25. Well, 25 goes into 160 5 times with 10 left over. So that gives me 5 and 10 25ths. Now I know my students are going to tell me X is equal to 6.4. Either way, right here, I know why they chose A, the choice 6. They rounded this using what they were taught to 6. But our answer is a real answer, and we need a whole number answer. And if we take 6 chaperones, that's not enough. We need 0.4 of another person. You can't have 0.4 of another person. So that's why the correct answer is 7. That's it. Actually, a topic there that we talked about back in Unit 1. This is the Unit 4. Understanding that this 6.4, since we need a whole number answer, 6 isn't good enough. We need 7. So that would be the cause for choosing A. Now, real quick, remember that 5 and 10/25 does reduce to 5 and 2/5 because we can divide 10 and 25 both by 5. And that would be equivalent, and I'm saying 5, and it should be a 6 here. It should be a 6 here. 25 goes into 166 times with 10 left over, not 5 times. But anyway, I'm glad I caught that. That's why you should use pencil, or at least an eraser. Now, the cool thing is, I can also go and analyze why did these couple students, 5 to be exact, get 40 and 30. And to get 40, just from the problems, we can see that they would have taken 80 divided by 2. To give the 40, which is incorrect. That's not using the proportion. In fact, they would need to multiply 80 by 2, at least for the way this proportion is set up. And for the answer of 3, what I can figure is that they took 80 divided it by 25 and got 3 and a little bit, and so they rounded the answer to 3. So that way, not only can the students that got the problem right know they got it right, I can provide pretty immediate next day feedback on, why students got particular problems wrong. And I know to spend time on this problem because the data told me I need to spend time on this problem. What I've showed you today is a little bit of the turning key application from Turning Technologies. I showed you how I plan on using it to collect data in my class and to drive instruction even the very next day. I'm using it in the context of a unit review before a unit exam. Very valuable data to go into class. We got halfway through the review today. Very valuable data. Not only on what problems I really need to focus on to start the period tomorrow, but get a gauge on how fast students can work in an allotted amount of time. We treated it kind of like a test a day. Since they were working in groups, 4 and 5, in a group, there was a little more chatter than there would be on test day. So not a clear indication of what's going on. As I said earlier, really had good conversations with my students today. Very directed questions. One of the best days I've had in a long time. Seriously should consider using Turning Key application in your classroom from Turning Technologies. Thanks for watching my video. Any feedback, comments, questions, feel free to leave one. Whether you're seeing this on my blog or on my YouTube channel or Facebook. If you're seeing it on Facebook, go to my blog, go to my YouTube channel. I'm going to be posting a link. Make a comment there. That'd be much appreciated. Bye-bye.